Hi, yes, I'm Brian Maranville from the NIST Center for Neutron Research, and thank you for the opportunity to speak here. This is my first time speaking or interacting with the HDF community like this, and I've been using HDF files for years, so this is very nice to be able to talk to people. And I think I was going to try to motivate why you would want to put HDF5 readers in the browser, but it seems like this motivation has been done very well ahead of me, so I don't have to spend much time trying to motivate this. So some of the things that I've been working on, our use case is very much what's been discussed in the most recent presentation. Is we have users that come and use our facility to do scattering experiments, and they don't typically do this as their primary line of research. So this is something they do once in a while. They don't really handle a lot of the HDF5s, at least the ones in the format that we provide. So we want to provide a very low barrier for entry for them. And so there are, as a facility, one thing that we've thought about supporting is having something built in to show the data that's taken at our facility, because we can build infrastructure to support something like h5web and h5 grove or HSTS. But then the users also will do processing on their data, and then after that it belongs to them. And so they need some viewer that they can, and some kind of system for interacting with their files that they own that are no longer part of our system, where we can share it through h5 grove or something like that. So we need something that has basically zero cost for people to start looking at their files, as was mentioned. So we're really aimed at these casual users that just have a few files. And my first stab at this, going historically here, was this JS5. So there's a nice library in Python called pyfive. That's a reimplementation of reading the actual format of HDF5. And I took that and ported it to JavaScript directly. And so this is very limited. It only supports, up through a couple. There's different formats for the different data structures inside the HDF5 files, and only some of them are implemented in here. But it handles quite a lot of the files that you'll find floating around on the web. You have to load your data into an array buffer, and it's read-only, because making it able to write would have been another layer of complexity that wasn't done in pyfive and also hasn't been added to JS5. One nice thing about it is that it's really tiny. So after it's all written and bundled and everything like that, it's 176 kilobytes to load this library and to read HDF files. And because this was the first one out there that we released, there are a number of packages that are using this just to look at biological data sets and this kind of thing. So there are other packages that are relying on this right now. It's not being maintained nearly as actively as the next library that I'll talk about. That's one that h5web is using. And here are the links that you can see for where you can get this from NPM or look at the development on GitHub. So you can just do npm install and get JS5 or h5wasm, the next one. So for data sets, it supports the simple data sets that are, the standard data types. Recently, ENUM, someone really wanted ENUM support, so that was added in, and string data sets. And then it's able to read, attributes, as you would expect. And it can support all the same types and attributes that are in data sets. And then it returns them as a JavaScript object with key value pairs. And then it supports all the built-in filters. It does shuffle and Fletcher 32. These are reimplementations directly in JavaScript. And then the deflate, we're borrowing from somebody else did this. The Paco library is just something you can load. Because of the NPM infrastructure with Node or with NPM packages, you can just pull in something and then use that and then build that into your final bundle. But there was an external request for making it easy to use externally defined filters, and in this case, at least in this package, this is one advantage of JS5, is that it's actually really easy to add new filters, because you just have to define a JavaScript function that takes a chunk of data, and then all you have to do is write one function that takes a chunk and transforms it. So that can be any external function, and then register it just by telling the library, this is the number of the filter and this is the function that it's connected to. So you just define one callback in JavaScript. So it's very, very simple, and it's very tiny. The downsides, of course, that this only covers a fraction of the files that are out there, and there's no support for array or compound data types, and you can't do slicing, so you can't pull a partial data set in to work with it. You have to get the whole thing. So that takes us to the next one. We started running into some of these limitations, and then there was all this development in Emscripten, which now supports compiling almost anything into wasm. So I compiled the libhdf5 into wasm. I've been using 1.12.1 as the base version but I think I was able to compile all of them basically. And then there's another C++ library that's actually built against the C API that has some functions for accessing data and working with it. And it uses the Emscripten virtual file system. So this is a virtual file system that comes with Emscripten. When you compile something, you can just add a virtual file system, or it's very easy to add it on. And so the way you load files in is you write them into the virtual file system, and then you're able to work with them just like you would in any C program. You can open a file and read it as long as it's been written to this virtual file system. And then after you bundle this all up, and including zlib for deflate, then it comes out to 3.2 megabytes. So this is a lot bigger, but still, I mean, 3.2 megabytes these days on the web is not a huge barrier for people to use it. And then you can see the development of it on GitHub, and then there's a package that you can install through npm. Data types, it can read any data set, and there's one caveat on this I realized as I was listening to the other talks. If there's a filter defined if there's a filter that's in the data that's not one of the ones that's been dynamically linked to this, then it won't load that data set. And that's probably something we could change so that it would just return raw bytes so that the users could work with that directly, just retrieving chunks. There's no API for retrieving the chunks directly right now. So you will get an error in the browser if you try to load a data set that has a filter that's not been implemented. One thing that I think it's nice that it does is it converts simple data types to the nearest native JavaScript type. There are these typed arrays that you can use in the browser, float32, and then these big uint64s and all these things. And these are very fast to work with in native JavaScript code. I mean, things have been optimized so much that sometimes V8 JavaScript code is as fast as native code written in C. And if the data type is not recognized, it just returns raw bytes. So if you have something really complicated, then it returns. It does not have read chunk right now, so that's not something that's been implemented. I see a question right there, but that's something that could be added. I mean, I've been also responding to user requests and adding things. I take pull requests. So it writes. The other thing about h5wasm that's different from JS5 is that you can also do writing. So you can write HDF files to this virtual file system. So you can create in a web application, you could create a whole new HDF file and write it out, and then have the byte array, and then you can download that if you want. So you can create new HDF. And you can also edit HDF files in the browser this way. And you can, when you're creating new data sets and attributes, you can manually specify the D type if it's one of these simple data types that's recognized. So the filters that are supported are the built-in ones that you would expect to be supported. The deflate and shuffle and fletcher32, and these are using the ones that are built into HDFlib. So except for the gzip one, which comes from. But that's Emscripten lets you build zlib and link against it. And then I had some other people that were working on another. It is possible to build the entire project as basically so it can be dynamically linked at runtime. That it's a little more complicated to do that, and there hasn't been enough demand to really work out the details of this. I did one proof of principle on this, so you can create dynamically loadable filters that can be linked. So you can use those, so you can mix and match all the filters that you want. Or if you can compile them, if they're written in a way that they can be compiled to WASM, then you can just statically link them if you know you're going to be building an application just where you know what types of filters you're going to be needing. So it has the slicing built in so that you can retrieve partial data sets based on sort of the slicing that's built into the HDFlib. And then there was some request for supporting Boolean data types. This is sort of a convention that h5py uses where you can write Boolean data sets with this particular enum structure. And so h5wasm supports reading and writing those, or just reading at this point. I was going to plan to support them for writing. So you can read in and it comes back as an array of true and false values in JavaScript. And then recently we added the toArray method, which converts, instead of returning a flat array when you request a slice, it'll actually reshape it into the shape in a nested JavaScript array, instead of returning just one big typed array that you can do with what you want. So in current use, we're using this at our facility. We have a lot of small HDF files. So this is really what was driving this, is that we have 1 or 2 megabyte HDF files, and we have like millions of them. So this is a way for users to quickly retrieve them. We have our HDF5 general viewer, and then there's some specific viewers. So then we have some specialized viewers that go way beyond the specialization of H5 Web, where a specific instrument has, a layout of detectors and this kind of thing, and it overlays, multiple detectors on top of each other. And so those are some very specialized users that load the HDF5 right in the browser and then do some transformations in JavaScript and then display it for you. And then recently, thanks to the very beautiful talk earlier, we've had integration with the H5 web viewer, and I think we're gonna try to adopt that as our standard viewer for all of our Nexus files, because instead of doing one locally, we don't have developers that are devoted to working on this at our facility. We're pretty small, so being able to leverage all the work that's being done on H5 web would be fantastic. And I think thanks to the collaboration that we now have with Loic, who I've never met except for virtually through this meeting, then we're hoping to roll out H5 web as our standard viewer for Nexus files. And then for future developments, some people have mentioned that the way that we're linking against the C API, things might be a little simpler for memory management and stuff if we switch to the C++ API for HDF5. It was a little harder for me to find documentation for that. And then if there's requests for more support for writing complicated data sets, some people wanted to do like streamed writes and this kind of thing, and I'll mention something about that in a moment. But that might take a lot of work, just try doing that. And then interestingly, there's been this development lately for doing these partial reads over the web, and that's something that you can actually do already. I did sort of a proof of principle of this real quickly, where you can, in the virtual file system that's built into Emscripten, you can do lazy loading so that if you request a range of bytes, it'll actually send out a range request over the web, and you can just retrieve parts of data sets. So if you had petabytes of data in a single file for some reason, you can load as much as you need to start processing it. So if you loaded the root folder, it would go and retrieve as many bytes as it needed. You can specify the chunk size that you want to retrieve. It could load as much as it needs to be able to get the structure of just that folder. And then when you start requesting data, it'll start doing seeks, virtual seeks on the file, and it'll go and get the pieces that it needs. And you can actually do this already. This is something that would already work. Because of some details about synchronous versus asynchronous loading, you have to do it in a web worker. This is sort of a specific thing to the way that JavaScript stuff works, but you can create a little web worker, and you send requests to the web worker, and then it can retrieve stuff for you and then return it in an asynchronous way. So that's an interesting development that might happen in the future. And then this is very, very recent. I started working with some of the people at Pyodide, and in the current tree for Pyodide, the H5 Pi has been compiled into Pyodide. So it's not in any of the releases, so you can't start using this right away. But if you build from source and then deploy your own Jupyter Lite or something like that, then you can start using basically H5 Pi in the browser. And this is very powerful, much more powerful than h5wasm, of course, because it has H5 Pi has been developed for years and is extremely powerful and does a lot of things. For various technical reasons, we ended up compiling against HDF version 1.13.1. And I'm not quite sure, I didn't hear from the developers when they're planning to put this into a major release. It's not in the next one, so maybe it's a little bit further down the road. That I don't know what their release schedule is like, but it's in the current master branch there. And that will allow you to load and work with HDF5 from Jupyter Lite. And there are a bunch of other, I didn't mention all of them on there, but there are a lot of online tools now for making notebooks. They're web native for doing JavaScript plus Python type stuff that use Pyodide. So I apologize, I went really fast through all those slides and I didn't show all the demos. I would have trouble loading up my web browser, I think, to show all the demos, but I'm going to end a little early. I hope that's okay. And I'd like to thank Loic for all of, the integration with H5 Web. That was a really collaborative process, and that went very well, I think. So that's something that we're going to use, and hopefully we gave some value back to them, so that this is a benefit for everybody. This is open source at its best, I think. So thank you, everybody.
Yep. Thanks for a great talk. I have a question. Any plans to return to JS5? I mean, where I'm coming from is, I don't know, I'm not a JavaScript programmer, but what are I would think to sort of make this more feature complete, you would have to rely on sort of the meta programming capabilities in JavaScript, and where do they stand? Do you do any meta programming there? Because you don't want to really write all the code to parse the file format primitives. You would rather write in C++, you would write templates or const expressions or something like that, rather than writing all that code yourself.
So the current like landscape for doing this type of development is very different today than it was when pyfive and JS5 were started. I mean, TypeScript is sort of the standard thing right now, and that offers a much more similar ergonomics to C++ in development and making templated stuff. And Loic is has done a lot of, I learned a lot of TypeScript by working with the H5 web people, and I think that would be, if you rewrote it just using something that's more structured like that, with templating and generics, it would probably go a lot faster. Right now, it's written in a way where it's literally functions that go through and do what you said. It's unpacking bytes one by one from the underlying file, just following the standard that's published on the HDF website, just trying to interpret that in words, reading it and trying to interpret it, and then writing code to match it.
Great. Any questions? Oh yeah.
Thanks. So did I understand it correctly that you are using just plain JavaScript without any other libraries to help you out?
In which one?
Itself,
for h5wasm or JS5, which one?
For h5wasm.
Oh, no, it doesn't have any dependencies. So it's a JavaScript library that's using a WebAssembly that's compiled, but they come together in one package, and so.
And then maybe the like connected question to that. What about the performance? Yeah, so did you try to render really a lot of points in the browser with this? So how did it perform actually?
I mean, it's hard to compare it directly to things that are. It's pretty fast. I mean, I've loaded several gigabytes datasets in there, and then slicing on them, and I mean, it's performant. I mean, it's not. JS5 is a little slower because it tends to run through loops to unpack things. It is somewhat designed with efficiency in mind. It loads things directly into typed arrays in the JavaScript side. So it's. I mean, in general, it's there have been a lot of these compilations of C code through Emscripten into WASM, and you tend to lose a little bit of performance, and so it's maybe half as fast or something like that as if it was running in C directly on your own system. And I would expect this is about the same.
I see. Sorry, this is like a subjective question, so I guess I will check it out myself. Thanks.
Any other questions?
Yes, it's again about the. I'm seeing the GitHub, and I see that you can load it with Node. Also, you can just call it from with a link to the HTTP page. So it's possible to use it if I want to use Cordova or something, to use a tablet, an iOS or Android application. It's possible to use already this library as it is. Will it run?
As long as it's something that can load, JavaScript and handle the WASM. I mean, it works in all the major browsers, and I'm not sure if in that context you would have access to sort of all of the JavaScript features that you need. It has to be reasonably recent. It has to support BigInt. So I think that's a reasonably recent version of JavaScript. So that's the limitation for using most of these.
Thank you.
Maybe so when you build this WebAssembly, would you need, like for Android, for example, an ARM-based, so an HDF5 library that was a binary that was compiled for ARM, probably?
No, once it's in the WebAssembly, then this is a standard that can be run anywhere that has a web context. So this is portable. Once it's WASM, then it's run anywhere that has a web interface. It doesn't depend on the architecture, because the running of the WebAssembly is handled by the browser implementation on that architecture. But the WASM itself is portable and is the same object that's used across all operating systems.
Great, thanks. And any other questions? Oh, sorry.
Hi, yeah, so for iodide, it said that you target 113.1. So
yes.
I don't know what the state of that software is, but the 113 branch is experimental releases, so the file format can change. and other things, I would probably target 112.2 and then switch to 114 when that comes out, because those would be stable. So,
Okay,
so you don't
that's
have
good
any
to know.
unpleasant surprises.
Yeah, and I think it was purely because it was easier to compile at the time, was 113.1. There were some issues with compiling 112 with the compiler chain. The compiler chain was a little bit old that they were using for pyodide, and so and there was some conflict where CMake was having some problems, and there were some errors trying to compile 112.1. But that's good to know.
Oh, if there's some problems, send us a comment, email, and then we'll fix that.
Okay. I don't know who, I'm sorry, I didn't know who was talking, so I don't know who to send the comment email to. But.
Sounded like Dana.
Dana, yeah, I'm Dana, the chief, the director of engineering.
Okay, thanks. Oh, let's see, is there a question in the chat? Let's see, was there a question? Hi there, somebody asked about the compatibility. Francesc was just answering a question that was asked this morning about the policy of the BLOSC library in file format. He just added a new FAQ to the repo answering this important question, and there is a link here. So I'm sure that will be in the recording, or yeah, we can capture that for you, or I can just click on it. I don't know if that's gonna, yeah, it will display. Okay.
Sorry, I have one last question. Brian, this is Loic speaking. Can you comment on the question about the support of virtual datasets and external link that was just asked just beforehand?
Oh, I apologize. Yeah, I meant to address that. I'd been trying to philosophically figure out how I wanted to approach this, because there's kind of an opportunity to do something different with the way it's set up purely in the web. You could have external data sets that are defined only by a URL, for instance, and that would be more useful to us in our use case than linking ones that are local. But you could certainly load two files into the virtual file system and do the traditional thing of referring to them locally in external links, and that should be straightforward to set up. And if that's something that's important, then that could be a ticket that could be resolved fairly quickly. So you just have to specify both of them, load them both into the virtual file system, or more than two. I mean, just two is the minimum. But any other files that would be referenced from the original data set, as long as they were all present within the virtual file system, they could be referenced the same way that it's done on disk anywhere else.
Okay,
does that answer the question?
That means that so far there is no support, but you are going to bring it soon.
If that's something that's important, sure, yeah. If you want to support ones that are, I wasn't sure if people wanted to do this I mean, there's an overhead of having to load every file that you would want to access in the virtual file system before you start accessing the file that references those other files.
Okay, thank you.